Let's look at question number 25, reverse nodes in K group. That question actually is the question number 24's extension. So in the question number 24, they require you reverse every two nodes. This question, they want you reverse every K nodes. So if K is 2, you need to reverse two nodes exactly same as the question number 24. If K is 3, so you need to reverse 3, 2, 1, and the rest two nodes is less than 3, so we need to keep it. Same rule for the question number 24. So the solution also we can copy from question. We copy this framework, right? We can copy this one as a framework to the question 25. We need to do some change. The change is here because in the question 24 we only need to reverse every two nodes. So two nodes we define the left and right. So here we have to define some array and new list nodes K, and we also need to define the second array, because inside the loop we need to have some buffer to get the next round's value. However, for this algorithm, the problem, this one is very simple to write, but the problem is you need to, for example, this is if K is 3, so you need to get all 3 nodes put into this array and then do the reverse inside this array, and then go to next turn, you get the nodes fill into this buffer and go to the buffer to the reverse. The problem is you need to visit each node 2 times. So for this algorithm, the time complexity is big O of 2n. We can see it's n, but if we can find some algorithm is big O of n, that is we only need half time. So I want to write that algorithm in this solution. We need to keep the same thing here. So if head is null, we will return head. All K is 1. If K is 1, you see here, they give a definition, K could be the 1. So K is 1, there's no reverse happen. So just return header. Then we need to define some reverse function. The whole strategy is we know we need to reverse every K nodes. So we get the nodes, reverse. So we do the reverse, and then we go to the next round, do the reverse until the end. If the end reverse is not enough. For example, here is a 2 element, but k is 3. So we need to reverse again to roll back to his original order. So the strategy is continue to the reverse k nodes. Then go to the next round. So this one, we visit each node only one time. So we write some function called reverse k. By this one, we give some virtual height. I will explain what is virtual height later. And then we give the k. Why we need to provide a virtual height, not the height? Because when this reverse happen, we need to know who is after reverse is a head element. So we define some virtual height. This virtual height next point to the node. From that node, we start to do the reverse. So the real node last, because after do the reverse, the first element will become the last element. They will get to the next. And then list node, the T2, T1 is last, and T2 here. If T1's next is now, so we do not need to do any reverse, right? One element, we need to skip it. Then let us to see what is going on if list equal to T1 dot next. So we have the 2 element, and then here we have list next. So every time when you do the reverse, you have to some variable to keep the next row. So T2's this is typo node next. Then we will to do this reverse. So we already have 1, so they will from the 1. Okay, how to do it? So T2 next will become the T1, and the T1 will become the T2, and the T2 will become the next, and the next will become the T2 dot next. So what happens is first T1 is 1, T2 is 2. So we let the T2 next point to the T1, and then let the T1 point to the T2, and the T2 point to 3. So next time we will let the T3 point to T2. So finally we build this order, right? Then we need to find some exception. So what is if this situation we do not have enough nodes to reach the k node. So in that one, if T2 is null, this means we don't have enough node. So, but we already do this reverse, so we need to roll back. So here, the last next will point to now, because the last is the first node, original first node. Here, because we already do this reverse, so we let it point to the now, and then virtual head will be the T1. From the T1, we need to do this reverse, rollback reverse, and we do the reverse K again, and we give the V head, and how long we need to reverse I1. This is not K, because we not reach the K, we already did the I1. This is the size we already did this reverse. We need rollback, so we give the I1. So after this one, we return now. So this hold the situation. If go to the end of this list, we do not have enough node to have K, so we need to roll back. Okay, when this function finished, we need to set up what is a new header. So next will be the T1. So here, T1 will point to the 3, and T2 point to the 4. So, but T1 will be the new header. So this is why we bring the virtual header in here. So we update who will use this one as a header. So we use this one. In the beginning, virtual headers next is point to 1. Now we update this to the pointer to 3. Then last is what is last? Last is in the beginning, the first element. So this one will become the T2. So now 1 point to 4. And if T2 is null, what it means for the T2 is null? It means the last one is, if, for example, this one have the 6 nodes. So we do the one turn, the second turn. If I finish the second turn, 6 already is the end of node, and the T2 will be null. So they exactly have the K times something, K times n nodes in this whole array. So in this one, we return now. Otherwise, we will return the last one. So we will return 1. So because of the next time, we will start from the 4. But if this K nodes do the reverse, we need to let 1 point to the new header in this K nodes. So we return this 1 in this case. Now we implement the main function here. So first, we have a virtual, we set up the virtual header. This one is a new list node, so it doesn't matter the value, but he will point to the original header. And we also need to define the return value. And then we do the view true. I want to use some break to jump out. So the list node we go to the virtual key. Here is a virtual header and key. Right. And then when he finish, if because in this one we update his next to the real header, so if return is now, we will set up return to the v headers next, so we get the real return value. And then we can let v header equal to v, and here we can change here if v header not now. So we update the v header. If the v header is now, we finish this one. So in this case, after rollback, or we do not find the next term. Okay, let's us try this code. We have some typo here. Okay, and try again. Return. Okay, I see. We have this one is typo. Try again. Okay, and submit it. Which line? 40. Okay. Oh, we need to make some test here. T2 not now. We do this one. Otherwise, we give it the null value. Okay. Okay, perfect. The speed is good. This is big O of N. Thank you for watching the video.